Good afternoon. And to start, I would like to thank you, John, and the UCL and all the organization for this opportunity. I will start by presenting myself. My name is Aida Guerra, and I'm Associate Professor at Aalborg UNESCO Center for PBL and Engineering, Science and Sustainability at Aalborg University. This is for my first time to actually pre-recorded a presentation, so I would like to apologize in advance for spelling or misspelling words or something, but let's hope this goes for the best. So the title of my talk is to address or not to address the SDGs in engineering education. That's no longer the question. And I stress the no in this expression and in this question because we are past beyond that stage. We know we must, and the question now is actually how we do it. So the aim of this talk and what I actually will address is the role of engineering education. And here engineering is between practice because this actually extends beyond engineering education. The role of engineering education in addressing the UN Sustainable Development Goals, the so-called SDGs. And I will actually, particularly focus on the competences to address the SDGs and on the students' perspectives and engagement. And I focus on the students. There's a lot of topics I could focus on, but I think the reason we engage in engineering education research and the reason we actually are here together is also because of our students and what the future holds them and the responsibility we actually feel in being educators and the role we play in their education. So I will focus on the students' perspectives, and also I will close this talk by reflecting on PBL and how it supports the integrations of the SDGs. A little bit of background, and at this stage it's unquestionable that sustainability is one major trend for engineering 2030. It's in all reports, it's in articles, and it's actually recognized by policymakers, by policy agendas, by professional organizations, and so on. And it actually is a trend that, and we cannot deny anymore. We cannot run away from it because there are proof, and we are close to a point of no return. And I'm talking about climate change, loss of diversity, and environmental degradation, armed conflict, poverty, inequality, and so on. So this is actually the sustainability challenges, sustainability problems, among others, of course. I'm just showing as an example. And if we look back in history, we can find events and drivers and milestones that can be connected also with the sustainable mindset, and that there were turnover points in history, like, for example, the Declaration of Human Rights and the child rights. And this actually events can go back to the 8th century. Here we actually focus in the last 6 years. Even the sustainable development has been around for some decades, maybe since environmental education back in the 60s with the Silent Spring book. But actually we will focus on this last 5 years and the 15 years we have, the 10 years, sorry, we have ahead. We are focused on the SDG and the transformation of the world that we have to do, the change that we have to do in order if we want to secure a future. And the Transforming a World 2030 Agenda for Sustainable Development is composed by 17 goals that actually refer to concrete actions to achieve by 2030 by all countries in the world. So this is also contextual. Each country should see which goal is meaningful and strategic to be embedded in their policies, in their national plans and strategies, and so on. And even though for the last decades we have been having a focus on education for sustainable development. And this actually was stressed, giving guidelines and everything by declarations that higher education institutions compromised with. That no longer exists. Actually, we have an SDG just for education. And this SDGs not only relates with the other SDGs, like for example, how to achieve gender equality or well-being or and everything. Education plays a role in that, but also what type of education we should aim for. This better education, this quality education, this long life learning education. So here we actually have to define what this education is, and also look into the changing drivers in the world, like the fast technological shifts, the global trends, the climate pressure, the demand for new skills and labor markets, the trending jobs, emerging jobs, disruptive technologies, and so on and so forth. So here we actually have technology plays a central role as well, not only on address sustainability problems, but also to provide solutions that can actually tackle those problems. We need to start by defining what do we mean by education for SDGs, engineering education for the SDGs. And this goes across all domains, professional type of education in each area of knowledge. We actually focus on systems thinking. So this goes just beyond the silo thinking on the disciplinary expertise. We actually have to see this in connection to other systems, social economic systems, environmental systems. Critical thinking also as the capability of questioning, of probing, strategic thinking as another one. So planning and foreseeing and reflect on multiple futures, consequence of actions, and so. We also refer to, there's also the reference to integrated problem solving and collaboration, and these actually refer the capability of analyze complex problems and actually provide suitable solutions. And this collaboration that is here is referred is beyond the technical and peer on the same expertise, on the same disciplinary collaboration. And this also goes beyond just the technical. This also refers to empathy and empathic leadership. Other three competences are anticipatory thinking, normative thinking, and self-awareness. Normative is the ability of actually think about the norms that drives one's action, the values, the principles. And self-awareness is actually the role a professional engineer, for example, or a citizen plays in the local community to fulfill and help to build a sustainable future. So these actually are important competences that are not only for the SDGs, but if we actually look into the trends like Industry 4.0, disruptive technology, new labor market trends, employability skills, these are also there. So this is just not out for the SDGs. The responsibility goes beyond that. And actually it's not only to know, but it's also able to do and to be. So here we have a more holistic approach to actually the education of a professional engineer that we need to consider not only cognitive, but non-cognitive aspects of education and learning outcomes as well. So giving these competences, this is giving this aims that actually show a turning point on the type of education we deliver. It's somehow a break from the traditional and previous paradigm. We are in a momentum, in a changing, a turning point. Can PBL be an answer? PBL emerged from practice actually with the aim to provide graduates with ready-to-use skills. So what type of PBL we are talking about? What type of elements, and what I'm going to actually talk about now, focusing on our experience and focusing on the studies we carry out at Aalborg University at the center. I'm going to focus what actually this has been showing us. And I will start by looking into before the SDGs, actually with the type of perspectives that a problem-based environment at the system level, the type of perspectives in sustainability, the discourse that was there in place. So there was a traditional reductionist and technocratic approach to it. So actually, this is the traditional paradigm of engineering education, and even in educational in general, that we have this disciplinary and this silo thinking approach. And we have to break that. That's related with system thinking. But specifically in engineering education, there's a challenge to balance the technical, actually to reduce the complexity and remove the contextual elements, to focus only on the technical problem, to balance this on the technical and contextual level. That's actually one perspectives on sustainability that we can find in literature, and then we can actually see as well in the PBL environment to some extent. Other perspectives is the focal on the environmental dimension of sustainability. And this actually brings challenges such as, if it's not environmental, then I don't have a role to play, then I cannot provide a solution because my field or my technical problems are more oriented to social aspects or to economic aspects. That's something also we could see. Students work with immigrants in some communities, in some municipalities, for example, in Aalborg, could not see this as an environmental and sustainability aspect by linking to the social dimension of it. So also this brings misconceptions regarding sustainability. The last one is actually this cut clear definitions. There's a lack of that. And this actually is what is the contributions that a specific and engineering fields can provide to sustainability. So in this way, when we ask our students and our staff to say, okay, to relate to sustainability, it's very difficult because it's an abstract and complex and interdisciplinary concept. So in this sense, sustainability needs also to be brought to the context of the discipline of the engineering field and see how the different disciplines can actually contribute to sustainable development and sustainability. And this has been before 2015 and gives us some perspectives on one discourse that was happening, and also why PBL could be an so actually at PBL, it's a PBL system. Aalborg University is a PBL system. So all universities, all programs, all semesters are problem project organized. And this means that by the end of each semester, students upload or has as a result of a problem solving process, a project report as a product, a solution. That is reported in that way as well. So in that sense, these project reports are uploaded in a database at AAU, in the Aalborg University Library. And in that project database, we actually went to see which projects could be related or contain sustainability aspects in that. And two things actually emerged from this screening. First was that we had an increase of engineering students, but even though the double of projects double, this means that there was an increase of student groups, the number of students, of group of students. We see that the projects containing sustainability aspects tripled. But what we could also see in this is that most of aspects are related to environmental aspects and take these technical solutions as the right solution. Just focus on the technical output and not so much on the impact of that technical output as well, on the level of why is this the correct solution for this problem. Was one point that we look into, and then we start actually thinking why if there is a student awakening of some sort, if students start to have an awareness, increase of awareness, can we actually understand better about that? So Virginie Servant-Michaelis at Aalborg University, at the center for the postdoc at our center, actually carry out a qualitative longitudinal study where she interviewed in different moments of students in the different moments of their study. And then she was able to categorize their awareness and how he actually evolved through these different moments in time in their educations. And this actually, what you are looking at is those four categories: no interest, little interest, basic interest, or active interest. And what is this distinguished basically these categories is moving from little awareness and no interest at all to actually become actively engaged, and sustainability aspects take a very important part of their studies and their lives. So this actually shows us that there is a change on students, and it's a qualitative study. And actually, 16 students were interviewed from 3 different studies. What we can observe before that, actually, we have these three programs. We have a more classic Servant-Michaelis interview for 3 students from 3 programs, from more classical engineering, like electronic systems, here represented as EE. Student number 1 as female. That's the nomenclature of of the students here, the program. Then mechanical engineer as ME1M, so student 1 from mechanical engineer, male. And then we have from mediology, that's ML2F, so student number 2, female. And then the third group, as more social oriented, is the BAM students. That is actually the Danish acronym for urban energy and environmental planning. So these 16 students from 3 different programs. What was actually observed that in the most classical technical educations, like engineering, electronic systems, and mechanical engineer, there's a shift of awareness. They move from basically no interest and little awareness to become quite aware, and actually what is the role they want to play, what the domain specific discipline can actually play to achieve the SDGs, and become step by step more engaged. So there is a development. In the BAM students, this is not so marked, as because also the students that choose to go to these programs already have an interest on environmental issues, as to speak. So this is actually shows that students have an evolution process in this if they are questioned and if they are actually put it in contact. And it's not only that, it's also the role that social media plays. Because in the last 2 years, there was a lot of movements, strikes around climate change. And there is a lot of movements and organizations working on this. So this is one type of data that we have regarding the SDGs. And what we are actually starting to doing now is, okay, if we want our students to become more aware, more active, more engaged, then what should we do? We actually need to understand what kind of resources they need. We are actually now unfolding the students' needs for the SDGs by starting having explorative conversations with them and say, okay, what are your interests? What are your motivations? What do you need? And are some of the preliminary outputs. Students actually find that it's very relevant that the identification of which SDGs have more meaning for what engineering fields and vice versa, in the sense that then there could be a ripple effect as the SDGs are all interlinked. Another interesting aspect is actually the need and the willing to co-create project proposals. Students would like to engage on creating and developing project proposals with their academic staff, where they could actually bring the SDGs in from the start, and we said, okay, how can we relate this with our technical learning, but also having a little impact, not solving big problems and change the world, but do make a difference on a little by little, step-by-step basis. So this is something of the outputs. We are still going on. We are still running this study at the moment. So this is just some preliminary outputs of this. So the question is, should we address? Yes, definitely yes. Can PBL be an answer? Yes, but we actually have to look into what kind of PBL we are talking about, what kind of curricula and what kind of PBL elements, as to speak. So in one side we can see, yes, the SDGs call for student-centered, complex problem-solving, interdisciplinary knowledge, collaboration, contextual learning, transformative, flexible and constructed curriculum. This is also something that comes from the student side. So on the other side, we have, okay, so then if we look into PBL, what kind of PBL we have? We need to have a strong problem orientation, that actually problems come from outside, have a societal meaning. We need to have a variation in problems, so it's not just disciplinary problems, but actually wicked, complex problems that they need to learn how to analyze and to solve. We also need to have variation in projects for this sort of problems. Maybe we should also have different type of projects. And in this comes the interplay of interdisciplinarity, students' ownership, and of course, this creates awareness and engagement because they need to be challenged. They want to be challenged for the SDGs. Variation in problems. Here is an example of a PBL curriculum where we actually can have a more an hybrid model that more student driven, where we have more open problems and nil structured as through the projects, and then we have more disciplinary projects to develop the fundamentals, the basics of engineering, the engineering science and the field, by narrowing the problems and putting more of the focus, so that there's a variation here that also is translated in a balance of education as well. I mentioned earlier the problem orientation. So here we actually look into where is the problem process start. And it's not by giving a problem that it's very, very well defined, in the sense that a lot of information is given. The goals are very clear and stated, and then the method is also known. So it's just a solving process case. In this sense, we actually need to bring in a more open problem that in context that actually students go out in and identify problematic situations. And then they can conceptualize from this sustainability, make a link as well. So this is a framework that could be used to structure and identify and solve problems. And we actually do this. So here is an example that we can provide a semester theme that has both a technical component in it, but also has a sub-theme or another that is the sustainability input to it. So here there is a dialect, there is an interplay between the field as the technical and the sustainability. And here they got into a narrow process as limiting the scope. So the final problem formulation actually gives a sustainability angle, the context where the problem is rooted. And here the problem is not defined by the students, but it's defined by someone that actually has the problem outside in the context, and actually the technology they can. Another example at Aalborg University at the moment is actually the broad interdisciplinary mega projects. This is an ambitious project, interdisciplinary, open collaboration with external partners, and mega projects in this context actually means that is a project or comes with a theme that is relevant for at least 4 faculties. Like this scheme shows. And then actually is going to be limited. So we start having a mega project that we have here a network that links different faculties, it links different programs and so on. So we start having a network of teams. Then the mega project can be divided in focus areas, and in these focus areas, there's challenges, and within the challenges, students actually formulate real problems, more narrow and concrete. In the example I'm going to show, the mega projects of this spring, we have two main themes, two main mega projects: simplifying sustainable living, the circle region. This is with municipality. These two mega projects, we have as focus areas the waste, the green consumption, transport, and mobility. And within these three, we can subdivide it in challenges where actually students go in and formulate a concrete project. So this is another example. So here is just some references I've been doing through the presentation, and then I actually finish the presentation as I start. Do we need to address? Yes, we are beyond that point. Can PBL be an answer? Yes, but the question here is how? How do we change? How do we create conditions for this learning? I would like to thank you for your attention, and I'm open for questions and discussions and to reflect with you about this topic. Thank you.